Welcome to the project demonstration of bidirectional power converter for electrical vehicle with charging feature and smart battery management system. So here we have the two features. One is the regenerative braking system, and also along with bidirectional power converter to charge a battery and to take the power from the battery to the motor. And when we switch off the power supply to the motor, when we are applying a brake on this motor, then this will act as a flywheel and it will start producing the voltage, and that will be given through this bidirectional power converter to the battery. And also we are going to measure the same so-called voltage. So this is called as a BMS. So the system will start measure the voltage from the dynamo, and that will be displayed on the LCD screen, and battery through these two voltage sensors, and that will be displayed continuously on the LCD. And whenever the battery voltage is less than 23 volts, so then the system microcontroller will switch on this electromagnetic relay. This blue color is the electromagnetic relay to allow the power from the generator to the battery. And also we have one more source, the transformer grid. So from this transformer we are going to charge a battery also whenever there is no power generated from this generator. So here we are using PMDC motor, which will act as a motor as well as a generator. So when we apply the brake, when we disable the power supply to this one, it will act as a generator. When we provide the power supply to that, it will act as a motor here. So the generated power will be given to the battery through this charging circuit. So let me explain the power flow from the generator. So here we can see dynamo, and this is a charging circuit which will act as a polarity corrector, this DB107 IC. So the DB107 is a IC version of full wave rectifier, so which will convert the alternating current input. So if we rotate in reverse direction also, so we can see that the forward direction and reverse direction, in both directions the current will be converted into the same polarity. So that will given as input to the battery, from there to this bidirectional converter, and from here to the battery through the relay, not directly, through the relay. Whenever the battery voltage is less, then only the battery will be charged when the microcontroller measure that and switch on the relay. So this is a power flow from the generator to the charging circuit to the bidirectional converter to the relay to the battery. And parallelly we are going to measuring the same voltage to the microcontroller board. And the next is from the 230 volts. So from 230 volts to there we can see one regulated power supply board which will convert the AC to DC. So there we are providing 230 volts AC inputs, and from there to step down 12 volts AC, and there we can see one more IC version of DB107 full wave rectifier, so which can handle up to maximum of 10 amps. So from there to the capacitor to smoothing purpose, and through the diodes to the same again bidirectional converter, from there to the relay to the battery here. Same 230 volts AC, 12 volts AC, 24 volts of AC. Why? Because we are going to use here 24 volts DC battery, as we are using 24 volts DC motor here, PMDC motor. So 230 volts AC to 24 volts AC, and from there to 24 volts DC with help of our capacitor and rectifier, and through the diodes directly given to this bidirectional converter, and from here to the relay to the batteries. Again parallelly we are going to measuring the battery voltage to the microcontroller at A0 A1 pin. So coming to this BMS system, so on this one we are using two voltage sensors. Each voltage sensor consists of 10 kilo ohm and 1 kilo ohm. So means we are going to divide the voltage, so 10:1 ratio, because the microcontroller can't measure the voltage which is above the 5 volts. So we should make that particular input voltage should be less than the 5 volts. So for that purpose we are dividing that to 10:1. So means if we are providing 10 volts inputs, microcontroller will get only 1 volt. So 10:1 ratio. So microcontroller will program in such a way that it will multiply with the 10. So then we will get the 10 volts that will be displayed on the LCD screen. And also parallelly we are going to control the pulse width modulation duty cycle to this MOSFET whenever the battery voltage is less to, and we are going to converting that to bidirectional one. So here this is a switch to on and off. So there we can see the generator voltage will be given to the charging circuits. So when it is on, so it will act as a motor, and off it acts as a dynamo. So that's why we are getting the back voltage which is given to the battery. So this is the adapter which will power supply for our motherboard. So when we switch on the kit, then there will be a welcome message, and this is the charger for the battery, right? So now we can see the voltage of the battery is 28.5, as we are using 24 volts, but we can get up to 28 volts, and we are providing the same voltage to the battery here. So when we on this, so the motor is rotating and there is no voltage, so I am offing that now. So you can see the back EMF generator voltage is 16.8 something. So as of now we are using the less flywheel weight on the motor, so that's why it is generating the less time voltage, right? We can see that. So in this manner we are going to generate the voltage from the motor, and when we apply the brake, so it's nothing but regenerative braking system, as well as it consists of the bidirectional DC to DC converter along with battery management system by using the PIC16F72 microcontroller. Right.